Welcome to the Unreal Engine Learning Theater here at GDC 2024. As always, my name is Matt Ostole. I am a Senior Developer Relations Technical Artist here at Epic Games, and I'm so glad y'all are here because I am in big trouble. You see, my art director over there, he saw the State of Unreal presentation, he saw Amy Hennig get up and talk about the virtues of nanite tessellation, and he sent me a text message and he said, Matt, I want nanite tessellation on all of our materials before GDC is over. Oh. It's a lot of materials. We have a big AAA game. We've got dozens of thousands of material instances, so many different permutations and textures. It's going to be a lot of clicking around. It's going to be a bunch of manual work, and I am a tech artist. I got into this job because I don't like to do the same thing twice. So I just wish that there was a way that I could accelerate my in-editor workflows. Oh, with editor utilities. That's a really good idea. Let's talk about those. So quick show of hands, who here has used editor utilities before? The number has been going up every time. I love that. So for the few of you who have used them, we've got some cool new stuff that I want to show off. For those of you unfamiliar, it is a blueprint-based system for scripting the editor instead of scripting the game, which is really powerful for tech artists and people who don't want to write code. There's a lot of great benefits. Now, the thing is, we've got a few different things that we need to do to make our nanite tessellation a fire with editor utilities. And we're going to start with asset action utilities, which is a great entry point into the system. Then we're going to talk about editor utility widgets, so we can do some, more complicated UI. I'm also going to show you how we can make them clickable toolbar buttons, so you can launch them really easily. Then we're going to extend what we can do with editor utilities using subsystems. And finally, we're going to run all this stuff asynchronously using editor utility tasks. And to demonstrate the power of editor utilities, this whole presentation is being run live in the editor using an editor utility that I've been working on for the last year or so to make it easier for me to run these live in-editor demos without having to context switch in and out of different software. We're all about that right now. So here's my presenter view. This is my little speaker's notes. I've got a little timer over here, forward, backward buttons, and this is an editor utility widget. So these are the kinds of things that you can do with editor utilities. But let's talk about those asset action utilities that I mentioned earlier. So these are little functions that you get to run and define in Blueprint, and they show up under this scripted asset actions context menu. We also have scripted actor actions. When you click on actors, does what it says on the tin. And if you ever want to inspect one of these, you can just shift click on it, and it will open the blueprint that contains the function that's being run. Now, the way I want to show you this, I've got all these material instances, and all these material instances need to have their parent changed. And I really don't want to have to click into each of those and change that parent variable and save them and wait for source control and all that fun stuff. So instead, we're going to automate this. And I mentioned earlier that these are a blueprint-based system. So you might be thinking to yourself, I shall make them from the blueprint submenu, and you would be wrong. Instead, we're going to make them from the editor utilities submenu. We're going to make an editor utility blueprint. That's how we get access to all the nice editor-only functionality. So editor utility blueprint, and we're going to make an asset action utility. This is for assets. And we're going to call it material instance utilities. And the first thing that you're going to do when you open this up is you are going to set the supported class, because you're going to get back from GDC and you're going to be so excited about editor utilities that you're going to go and you're going to make dozens, hundreds of these, and it's going to fill up that context menu, and it's going to be difficult to organize. So we're going to set the supported class for this utility. We know that we're operating on material instance constants, so we're going to put that in there. And now all of the functions on this utility will only show up when we have material instances selected in the content browser. And each of these things that show up in the content browser, these are going to be functions. So we're going to make a change parent function. So now I can go into my material instances folder, and we can see now I have a scripted asset actions change parent. Great. But again, you're going to make dozens or hundreds of these, and you're going to have to organize them because you might have global functions that will affect multiple types of assets as opposed to a specific type of asset. So let's take that organization one level deeper by setting the category of the function to materials. Now, if I compile and run in here, you see it's scripted asset actions materials change parent. So it helps us organize these functions a little better. But you might have a function on your asset action utility that you don't want to be visible to the user in that content browser menu. So you just set call in editor to false. And now if I right click on this, you see I have no scripted asset actions for materials. So organization aside, organization done. I'm going to turn call in editor back on, and we're going to get into this. Now, the first thing that you want to do with your editor utilities is undo them, because you don't want to have to make your user fight through and undo manually a bunch of actions. This is a change parent operation. We want the undo button to work and undo everything that happened when we changed parents. So the first thing we have to do to get that working is we have to talk to the undo system and say, I am beginning a new transaction. And it's like we have a little receipt printer over here, and it just pops up a little paper because it knows it's got some work to do. So the title of that receipt is going to be change parent. And then we are working on assets, so we're going to get selected assets. And then we for each loop across all those assets. And we're going to cast them to material instance constant. And once we've done that, we are going to transact the object. And that's going to write the name of that asset on our little receipt printer over here, so that when we go to return our items, we have a whole list of everything that we've worked on. And then the real meat and potatoes here is set material instance parent. So we can plug that in, connect our instance up to that, and then after we're done with all that, we're going to check out loaded assets, because of course we're using source control, right? And if you're not, that's okay. This function will fail silently. You don't have to worry about it too much. Then we're going to call save loaded assets. And once we're done with that, we're going to call end transaction. And that will cut off the receipt, and it'll hand the receipt to us so that when we make changes to these assets, we can just return that receipt. Now, all I have to do is right-click on all these assets, go to my function, and it will change the parent on all of these materials. But I noticed that I didn't set the parent that the material should change to, so I'm going to undo that operation real quick. Easy, done. And I'm going to figure out how to get a value into this new parent input, because we don't want users to have to go into this blueprint to change that value. We want to expose that value to the user so that they can change it themselves. But we don't want to have to go through and make an entire editor utility widget for just this little function. So I'm going to show you a fun trick. We're going to drag that parent pin all the way over to our function input node, and we drop it on there, and it automatically creates a function input of the correct type. And this is true for all blueprints, by the way. But I don't like this line going all the way across my blueprint. That's hard to read, so I'm going to alt-click to delete that line, and then I will call get new parent, because all inputs on a function are also local variables. So that's a fun little blueprint pro tip for you. So now I think we're ready to roll. Now I can select all of these, right-click, scripted asset actions, materials, change parent, and it pops up a little modal dialog. I love that. It pops up a little modal dialog with all of the inputs that you specified on that function node. So now we can get this working right and change these to my GDC default material, hit OK, bada bing, bada boom. Now it has changed the parent on all of these materials. So that's all well and good, you say. But Matt, I need more. I need a more complicated UI. I need to interact with my users. I need feedback from them. They want instantaneous control. How do I do that? Well, that's what editor utility widgets are for. And you might think to yourself, editor utility widget. I shall make this from the user interface widget blueprint. Right? No. Well, sort of. We added this recently. You can go to asset actions and convert a user widget to an editor utility widget. But I would prefer if you made these from the editor utility widget submenu, just like we did for our blueprints. Now, this is not a UMG demo, and I am not a UI artist, so we're going to take a look at one I made earlier, and this is just a little utility that toggles the directional light on and off. Really fancy stuff. And to run this, I have this little button up in the top left called Run Editor Utility Widget, and this is fairly new. I know it's not in 5.4. I know it's not in UE4. I don't know where it came in the UE5 cycle, but I can just click it to run my widget, and now I can toggle my directional light on and off. Ooh, ah. And then my art director comes along and says, Matt, this is really cool. I want this to work in Play in Editor. And I say, great, just hit Play in Editor. And then, oh no, it's grayed out. I can't click on it. Engine kaput. So that's all right. We've got an easy fix for this. So we go into our graph, we go to our class settings, and down here we have is enabled in Pi. Click, compile, run, and now I can play in Editor. And when I play in Editor, now my widget works, and I can toggle the directional light off and on, which is exciting. So the tricky thing, though, right, we talked about this earlier, we don't want our users to have to go into a blueprint to do a thing. We don't want them to go open this blueprint to run the utility widget. That's okay. They can also run it from the content browser. They can right-click on it and run Editor Utility Widget. But this isn't really a great way to surface these to our users. We want to present our users with the widgets that are important to them. And the way we can do that is through the Tools menu or through the toolbar. So you notice that's not a default toolbar button. I added that myself, and that opens my little example widget. And the way I do that is with Python. So I can go into my project settings, and I will show you the Python startup script that runs at startup to register the widget button to the toolbar. And that looks a little bit like this. Now, don't worry about copying down this code or taking pictures of it or anything. I will have a link at the end of the show to an Epic Developer Community article with this snippet and a few more snippets that I'm going to talk about throughout the show. I just wanted to show you what this looks like. The other option we have is doing it through C++. So I've got these widgets, these buttons up here, and these launch respectively my speakers view and the slide editor that I use if I want to modify these slides. And these are all registered by my plugin. And when I made the plugin, I made it starting with this editor toolbar button template, basically. And it gives you the ability to register a button to the toolbar, and it will open a Slate widget. But we don't really want to use Slate. This is in the Slate demo. So I'm going to have a snippet about how you can use this to launch a editor utility widget, again, in the links at the end of the show. Very briefly, this is what that C++ looks like. There's a couple of spoilers in there, but don't worry about it. And you may be saying to yourself, Matt, you are a tech artist. Why are you talking about C++? I did not sign up for this. I barely signed up for blueprints. It's okay. There are a few things that you get when you open your heart to C++ that help you push your editor utility work further. And the first is project settings. So those toolbar buttons for my project, for my plugin, those are registered by the plugin, but I use a different show control panel depending on which project I'm working in. And I don't want to have my project re-register those widgets. It's a whole thing, a bunch of duplicated code. So I have a project setting where I can specify which widget should be run when we click on those buttons. The more important thing that we get when we open our hearts to C++ is subsystems. And these are a really good way to expose functionality to Blueprint that wasn't previously there without us having to make any engine modifications and without adding a lot of extra bloat to our runtime classes. So we're going to use actually a child of uEditor subsystem to do a couple of things, because it turns out that tessellation enabled is not a U property on a material. You can't change it in Blueprint. But if I make a function that I expose to Blueprint to set that value through C++, I am now a winner. So we need set tessellation enabled and we need set displacement. And this is the level of C++ that I'm asking you for. Nothing super complicated. You don't have to allocate your own memory. This is just a get node. This is just a wire. This is a struct. This is a setting. And we're setting a value to that setting. This is the level of C++ that I'm asking you for, if you so choose. So let's start getting this thing put together. So I've got this rock here from Quixel Megascans, and I've got a default material for it that looks like this. I know. But more importantly with this, I have a displacement and roughness texture already, so we're going to use these to our advantage. But before we get into that, I want to talk about editor utility tasks. Because, again, we've got a big AAA project. We're going to have to batch over dozens and dozens and dozens of assets, and we don't want the editor to lock up while we do this. And the way we do this is with the editor utility task. We fire it off, and it goes off in the corner. It does its little work, and occasionally it will tell you how it went, and occasionally you'll be able to cancel it. So what I'm going to do is I'm going to make one first. I'm going to show you how to make one. Then I'm going to show you how to call it and get it to run, and then we're going to go back to the task, and we're going to put it all together. So it is an editor utility blueprint, so we're going to make it. From there, editor utility task. And we're going to call this EUT tessellation. And we're going to open this up, and all we need to do for now is this event begin execution, set notification, so set task notification. We'll use a literal text for that. And we'll say, hello, GDC. And then we're going to add a delay, just so we can see this working. We'll plug that in. We'll set the delay to about 5 seconds. And you notice this world context object pin. So for those of you unfamiliar with editor utilities, you may not have seen this pin before. And this just, we need to know what context in which we should execute this delay, and we need the editor world for that. So we're going to get the editor world through the Unreal Editor subsystem. See, subsystems come into play a lot. And we'll say get editor world. So now the editor is going to be doing this delay for us. And then finally, and most importantly, we're going to call finish executing task. Now, once we've done that, we can save it. And now we need to go into our material utilities library. So I made another one of these with the supported class set to material. And we'll make a new function called tessellationifier, because this is what's going to show up in our context menu. And all we have to do here is construct the object from class. So this creates the object out of thin air, and it is our tessellation task. And then we're going to use the editor utility subsystem to register and execute the task. So this lets us fire off something asynchronously, even though we're inside a function and not inside the event graph. And this is all we need to do to launch our task. Very, very simple. So we can close this out, and now we can start focusing on this. And I'll show you really briefly what this looks like. So I can come in here, I right-click on this material, and I click on tessellationifier, and it pops up this little task. It lets us know what it's doing. It says, hello, GDC, and we have a little cancel button, and it'll let us know when it's done. So let's actually do the thing. So the first thing we do, because we're affecting assets, we are going to begin transaction, and then we are going to get selected assets. And the keen-eyed among you will notice that we are doing the same thing twice, which we don't want to do. This is the same code that we used earlier. This code is going to show up a lot in your editor utilities. If only there was a way that we could put these in some sort of library of functions. And unfortunately, prior to 5.4, we only had blueprint function libraries which only exposed gameplay code and not editor code. And in 5.4, we've added editor utility function libraries. So when you go into the content browser, editor utility blueprint, we now have editor function library. And I actually made one earlier that lets us condense, begin transaction, and get selected assets, and return those assets, and check out, save, and end transaction. So now I can condense all of that functionality into a little static library that I get to use. So we'll start out with begin transaction and get selected assets. And we can use that world context pin we had earlier. And our context here is going to be tessellation. And of course, we're going to loop over all these assets. But because we want to be able to cancel this, I need to use a for each with break. So for each loop with break, and then off of this loop, I'll do a branch, and off that branch, my condition will be was cancel requested. So if you click that cancel button, it flips this bit, and now we can, at the top of our iteration loop, decide whether or not we should continue. So if cancel was requested, we can break out of the loop, and if it wasn't requested, we can continue on. And we will continue on by casting our each to a material. And then from that material, of course, we first have to transact the object. And before we get too deep into things, we're going to use my project subsystem that I talked about earlier to set tessellation enabled on that material. And we will also set the displacement parameters So set displacement that I wrote for my project subsystem and connect the material up there. And I'm going to set the magnitude a little high just so we can really see this working. And then I'll set the center to 0.5. Now it gets really fun. So there is a way through blueprints to add nodes to a material, which is really wild. It's called the Material Editing Library. And so the first thing we're going to do is create material expression, and it will create that expression at this position in this material. And the expression class we're going to use is a texture parameter 2D, because of course we want to expose this as a parameter to our users. Then of course we need to cast to material, cast to texture parameter 2D, so that we get access to all of that functionality. Then we will do a set texture, so we can set the default texture to the Icelandic rock that we had earlier, our displacement texture. And because that is a masks texture, we need to set the sampler type of that node. We'll set that by default to masks. So now we're going to have a parameter in our material, but we need to connect it up. And unfortunately, the displacement input pin is not something we can connect to through Blueprint natively, but that's okay because I also made a function in my project subsystem to connect expression to displacement. So it'll let us connect our texture parameter 2D expression to the displacement input pin of our material. And then I know that the displacement texture is in the red channel, so the output that we're connecting is R for red. And then finally, we'll go back to the beginning, we'll grab our material all the way to the end, and we'll call recompile material, just to make sure everything's working. That's like hitting the apply button. And then, because we're done looping over everything, we will use our checkout, save, and end transaction function. So we'll check out those assets and save them, and we'll use that world context pin we used earlier. And then, very importantly, we call finish executing task. So that's all we need to do. So now we can go over to our asset, and I want to show you how this works. I will close that content browser and Control B, grab my material, right-click, scripted asset actions, tessellationifier, and it will run a little quickly because we're only operating on one material, but hopefully now you can see we get a little bit more detail out of the shadows. The normal map, because we've now got some displacement to it, we get the object casting shadows on itself that we wouldn't normally get. Hopefully that's visible. And now our art director is really happy. But of course, this isn't the only thing that you need to do to apply this to your project, right? I skipped over a lot of stuff there because it's going to depend on your project and depend on your project's needs. You're going to have to build this to fit your own project, get the right textures, connect the right nodes, set the values properly on the material instances. But I think you have what you need from here to build that for yourself, for your project, if you want to do it. And in fact, I actually made one earlier that we're going to show. So I'm going to go into my project's materials here, and I can select all these materials, scripted asset actions, and run the example I made earlier, and it's going to go through and it's going to grab the material instances and update those values and find the right textures and loop through the asset registry and all that fun stuff. And when it wraps up, now all of my materials have nanite tessellation applied to them. And you can see, like, as I move the light around, we get some really deep shadows in that old, crusty, dry wood. And my art director is so happy and so excited that I finally got this working. And then my rendering engineer is going to run from stage left and chase me off stage because I put tessellation on everything. So what did we learn today? Well, we learned how to use action utilities to access, to expose functionality to our users. We learned how to organize that functionality. We also learned how we can use subsystems to extend what is possible with editor utilities. And we learned how to run things asynchronously using editor utility tasks. Now, of course, I am kind and generous. I promised links. I give you links. This is a QR code to my link tree that's going to have a bunch of resources to help you on your editor utility journey. And with that, thank you all so much for your time and attention. I'm Matt Ostale, and remember, thank your conference associates, tip your waitstaff, and try the veal.